Thank you very much, Bill, and thank you for the invitation to speak here today. I'm going to talk to you today about a decision analytic process called value of information analysis, and it's essentially a decision-centric perspective on emerging science. So I'll talk about what it means to be decision-centric and how this analysis might help to the discussion as to how we prioritize our information gathering activities and how we understand the role of information in risk assessment and risk management. Trouble here. So I'm going to just talk quickly about ideas from the Science and Decisions book. This is the National Research Council 2009. I'll define value of information, and I'll make an important distinction that we'll talk about later, which is the distinction between formal value of information and informal value of information analysis. Talk also about value of methods and value of information systems. I'm then going to try to crystallize the important issue that we need to add when we talk about value of information analysis, and that's an altered decision outcome pathway. So yesterday we heard a lot of discussion about altered outcomes with respect to the biological system. Value of information analysis asks you to understand an altered decision outcome as a result of the availability of the information that you're providing. So I'll explain that. Also want to talk about mapping decision contexts and the value of model-based reasoning. So the Silver Book, as it's sometimes called, is shown on the right of your slide, and with respect to value of information analysis, there were a number of ideas from Science and Decisions that are relevant here. One is the enhanced role of problem formulation. So this is a phase in risk assessment activities that comes essentially before the more technical scientific work of risk assessment occurs, and it's considered terribly important to increase the utility of risk assessment, to make sure that it's actually serving the decision maker with the information that the decision maker requires. Part of that problem formulation exercise, and a terribly important ingredient that was proposed, was the need for the upfront identification of decision-making options. Now, this is not to go so far as to say that we need to know exactly what the decision maker is thinking and every possible option they may have, but we need to be contemplating the nature of the decision, the nature of the discrimination task that the decision maker is faced with. The other thing that was discussed is the need for stopping criteria in risk assessment. Risk assessment is based in science, of course. Science, to its great credit, has no natural limit, no natural stopping. The problem is when we take the scientific approach into risk assessment, we inherit the no natural stopping problem. Risk assessment as a decision support activity requires stopping criteria. We need to know when to stop. And that's a challenge for all of us. So the other thing the Science and Decisions Committee discussed was value of information and value of information light. I put it that way. I don't think that's how the committee put it. It's essentially an informal value of information exercise, and we'll talk about why that is important. Also talk about value of methods, which is a way of valuing things which are not necessarily information. They're procedures and practices that we sometimes advocate for, but don't necessarily place a value on what exactly they contribute to the decision-making environment. So this slide is the sort of organizing risk-based decision-making framework that the committee suggested. I'm not suggesting that you read this. I'm actually going to shrink this down and just show you in how many places decision-making options are contemplated right up front in the problem formulation and the planning exercises associated with risk assessment. Also in the exposure assessment, since most of the decision makers' options will relate to their ability to control exposure in one way or another. The risk characterization step will speak specifically to the benefits associated with options that the decision maker may have. And so on through the process, we're constantly keeping a focus on decision-making options. If in fact we do that, and we haven't it's not easy to do this, but if in fact we do this, this does give us the possibility of doing value of information analysis. So just a quick cartoon here about when we decide for ourselves how important our work is to decision making, we tend to use something analogous to this cartoon here, which is an elaborate discussion of the nature of our work, how important the decision making is, and how important the decisions are, and then the link between our work and that decision is generally described in somewhat miraculous terms, that magically our information is converted into a much better situation for the decision maker and the public. And while some of that might be true, we tend to not have any way of making that linkage explicit. So what is value of information? Value of information analysis is a decision-centric valuation of the benefit of new information that would reduce uncertainty. So it's decision-centric in the sense that it depends on the decision maker as opposed to the scientist. What the scientific community may think is, for temporarily, for the purpose of this analysis, largely irrelevant. The question here is, given that the previous bullet says that we're talking about the benefit of new information, we have to ask ourselves, how exactly does new information generate benefit? We can describe that in rather vague terms, that it gives us insight and all sorts of other things, but where does the rubber hit the road in terms of information actually generating benefit? And information generates benefit in this mode of analysis by reducing the likelihood and severity of adverse outcomes from decisions. So it's rather a different way of thinking. But you will notice we're talking again about likelihood and severity, and we have the word outcomes, but the hazard is related to the availability of information and the need to make a decision. We'll come back to that a little bit later. So it's also important to talk about what value of information is not, because when people immediately think about value of information, they often think in their own usual way. Value of information is not equal to something being interesting or publishable. It's not equal to it being scientifically important. It may sometimes be equal to scientifically important, but it's not inherently equal to scientifically important. The other thing that value of information is not is it is not transferable to other decision contexts or other times. So if I suggest that a certain bit of information is or is not valuable in this context right now, that there's no reason to suggest that that be extrapolated or transferred to any other context or any other time. That's an important distinction. So some of the properties of value of information analysis is that it's very dynamic. It's very complicated because the decision-making environment is complicated. If value of information were not complicated, it's probably not characterizing decision-making. For example, which information, if you're considering two pieces of information, which information comes first strongly influences the value of the one that comes second. So two pieces of information, A and B, information A, if it comes first, is very valuable. Information B could be made more or less valuable by the presence of information A. So it's very dynamic. It's often counterintuitive, which is often a good thing, because for this particular type of reasoning, the human mind is particularly poorly wired. We have lots of evidence of that, and there's no reason to doubt that we somehow magically, despite not being able to manage probability numbers in our head at any other time, can magically update our estimates of uncertainty in the presence of information and do good analyses of how important that information is. A good example is at the bottom of the slide, where we talk about things that we wouldn't often even put in the same ballpark of value. If I were to do a 50-person survey on the use of a particular consumer product, that doesn't sound terribly publishable. I'm not going to get promoted. There's all sorts of reasons not to value that information. If I did a new two-generation primate study, I could make all sorts of great arguments as to why that is an incredibly valuable piece of information, and my grant application would be rather full of strongly worded linkages to the benefit of doing this. However, in a value of information context, at a particular time with a particular amount of information, this 50-person survey on the use of consumer products, in other words, how do people use it, or how many people use it, where you're simply getting a little bit of information as to how commonly this is used, could be, in that context, 10, 100, 1,000 times more valuable than this study in this context at this time. So that's why it's counterintuitive, but if you're really interested in supporting a decision maker, the fact that it's counterintuitive is entirely appropriate because it corrects your mental model of what's important at the time. So I'm going to spend exactly one slide on what you'll find if you look up value of information analysis in the formal literature. And you'll see that it's a formal decision analytic technique. And essentially what it does is it calculates the difference between the expected benefit that you would get given new information. So the decision maker is making a decision, and it will have some benefit for society, either in protecting, choosing an appropriate level of protection or other benefits that might accrue. And it's the difference between that situation and that same decision without the information. So it's really an incremental valuation of the benefits that you can expect given the information being available. And if you're interested in that literature, you can see a very good review article very much directed at this domain, environmental health decision making, by Yokota and colleagues in risk analysis. But just to give you an idea, the information in this calculation, the information that you see in this calculation is the only difference between the two things on the either side of this minus sign in the equation. It's the same calculation, but in the first integrand you see the information, which is a change in your state of knowledge given a test result. So that's exactly how it works. It's a fairly simple concept, and depending on how much you love integrals, it can be even calculated. This is the value of information perspective offered by the Silver Book. And what you see here is essentially at the top of the screen a standard risk assessment problem. So you have information on risk, you have information on risk reduction, you have information on what things might cost, or countervailing risks if they happen to exist. You also have additional information which may have nothing to do with all of those things. And at any point in time, the decision maker will have a preference as a result of all of that information available at the time. On the bottom left of the screen, you see various opportunities to gather new information, which can be as diverse as possible. Value of information analysis essentially knows no boundaries. If you're willing to reduce uncertainty, it can value that reduction in uncertainty. Whether it's the capital cost of the equipment to clean up the problem, whether it's a survey, as I mentioned, of the usage patterns of some particular substance, etc., all of those things are opportunities to gather information. Value of information analysis essentially applies that information to the baseline situation and tries to determine what benefit to the decision maker might accrue by essentially simulating, if that were known, if that study were done, what would be known, what would that allow the decision maker to do differently, what adverse outcomes from decision making could be avoided. So you can think of it, and I'll come back to this a little bit later, we're essentially talking about a system at the top of the screen, and we're perturbing it with information, and we're detecting its response, and whether that's an adverse or beneficial response. I'll just speak for a few moments about value of methods analysis, because many of the things that we're asked to do as part of risk assessment aren't exactly gathering information. They're doing all sorts of other activities that are essentially required at various degrees, everything from peer review, stakeholder involvement, things that you might do to make things happen more quickly, and also lots of elaborate modeling methodologies which may simply provide more insight. It's not clearly that they're a matter of information. In a very analogous fashion, we can look at the baseline situation as to how the risk assessment process will unfold and ask if any of these things on the bottom left of the screen, these opportunities to enhance decision-making more broadly, are particularly important at this place and this time. Again, very decision context sensitive. Is a peer review required all the time? Is a Is a full literature review going back to 1960 required all of the time, etc.? All of these things can be essentially put into a similar reasoning platform to determine what do we need to do in this place, in this time, for this decision. I'm not going to spend much time on this, but this is actually particularly relevant to a lot of the discussion that was on yesterday, which is the value of an information system. So we would run the risk if we considered value of information only one decision at a time. We really need to understand all of the decisions that are downstream of any information that we gather, and the ability to put it into an information system that truly makes it available to a wide spectrum of decision makers has again, is a natural extension to the value of information. We simply take information and we turn it into information systems, and we can talk about the resolution, the timeliness, the quality of that information, and the curation of it in that environment. We can also talk about not just a single decision, but an entire class or series of decisions that would benefit from the availability of an information system. We don't usually talk like that except in very vague terms, but it's a natural extension of the value of information concept. So what are some of the challenges in estimating the impact or the value of information? And I choose impact sometimes because valuation often means to people that it's all about money. It doesn't necessarily have to be the metric for value of information. It could be a much broader impact metric. But it's difficult to do when you don't know what options the decision maker is contemplating. That's why I focused earlier on the focus on the availability of decision-making options. You don't know how the decision maker chooses among the options. You are unwilling to describe your current state of uncertainty. You can't contemplate the value of new information if you're not willing to at least spend some effort to describe your current level of uncertainty and how that uncertainty would be changed given new information. So, and obviously, and as many people are likely to discuss in this area, you need to characterize the predictive quality and therefore the weight that you can ascribe to the new evidence as it's added and integrated into the pool of available knowledge. So the value of information depends on what you already know. So I'm going to give you a quick break from all of my chatter and talk about a value of information problem. Here you see some people up in a balloon. They're saying, I'm lost. Can you tell me where I am? And this person on the ground says, well, sure, you're 30 feet off the ground. The person has seen this before. It says, you must be a risk assessor. And the person on the ground is pleased to realize that their technical capacity is so apparent from 30 feet in the air and says, oh, why, yes, how did you know that I was a risk assessor? Because what you told me was technically correct, but just as I would have expected, it's of absolutely no use. Oh, and then this person has seen that before. Then you must be a risk manager. Why, yes, I am. How did you know that? That's easy. You don't know where you are, what you want, or where you're going. You're in the same position now as you were before you asked for my help, but now it's my fault. So that's a value of information problem. The information was technically accurate, but you can imagine, and if the person had thought about it a little bit, they might have realized that the 30 feet off the ground part is probably the one thing the person did know, and probably would have preferred just about any other information other than that. At the same time, the risk manager clearly wasn't very clear. How's that for redundant? The risk manager wasn't very clear as to what they wanted to know. They just simply said, where am I? So the information was correct. So the value of information problem is a two-sided problem. It's not just the provider, it's the decision maker, and everybody along the way who processes that information, which we haven't really talked about in this meeting. We talk a lot about provision of information. We haven't talked about the 40 stages of processing it goes through before it meets the decision maker. Okay, so the Silver Book Committee recommended increased application of informal value of information. And so what that really means, because we tend not to sit around and solve integrals, some of us do, We don't sit around and solve that integral that I described earlier. But what we do need is to capture the same thinking that information is asking. We want to create a clear causal link between a particular piece of information, the magnitude of uncertainty reduction that provides, and the reason why the decision maker with that reduced uncertainty is likely to make a better and different choice. So if the decision maker does not make a different choice, and is very unlikely to do so regardless of what information you might provide from a particular test system, the value of information is essentially zero. One of the goals of doing this is to create stopping criteria for risk assessment. If you are at a situation where the uncertainty is such that the decision maker's options are clear enough and no amount of information that you can reasonably capture under reasonably near-term circumstances is likely to change that choice, then we have a basis for stopping a risk assessment. Okay. For those people who are contemplating this and wondering how can I think about this more biologically? Because this sounds like a lot of fuzzy decision theory, and that's not what I do. Another way of thinking about value of information is essentially as a risk assessment of decision making. So decision making is a system, and you're trying to understand how information affects that system. So the hazard that we're talking about is the lack of information to reduce uncertainties in a decision. And we want to know how that particular absence of information, or you could think of it almost as the absence of a nutrient, if you like, how that affects the ultimate decision system. The pathway perturbation, since we talk a lot about that in systems biology, is the effect of that information on the beliefs of people through the system that process the information that alters estimates of risk and other decision-relevant variables, be they cost or countervailing risks if we're talking about substitution problems. All of the other decision-relevant variables can be affected by information. But what you're really affecting is people's beliefs. If you don't change people's beliefs, then you haven't changed the decision-making environment. The adverse outcome that we're talking about in this meta-risk assessment, if you like, is an adverse outcome of losses, be they health or economic or otherwise, that would be avoided had the information been available. So we can do a quick analogy to systems biology. On the left of this panel, try to move this little thing out of the way here. On the left of this panel, you see the series of steps that we talk about when doing a chemical risk assessment, and we talk a little bit in more detail here about sort of some of the events that we talk about in systems biology. We have a source, we have a pathway to the receptor, we may have multiple other sources that are impinging upon us along the way. We have other health determinants that we need to consider. What is the general state of this person that we're talking about, and their ability to tolerate and otherwise be exposed to this chemical? What is the intake route? What are the pharmacokinetics that deliver that to various organ systems? What are then the molecular events? How does the network respond to this molecular events? What is the biological system's immediate effect? How does the system overall respond? What is the adverse or beneficial effect of that exposure that we're talking about? And then we characterize risk at the bottom of this screen as a function of the likelihood and the severity of that effect. So we're essentially calculating likelihoods all the way along through this pathway, and then we're deciding how severe the effect is at the end of the day. And then in an ideal world, we would repeat that for the next individual if we could do things at that scale. On the right, you have an entirely analogous system where you have a source. So that's many of the people in this room are sources of information, and they transmit that information in various ways. But they transmit that information in a very noisy environment. There's a lot of other people providing information. The information doesn't always agree with each other. It's very noisy, and the system only has a certain amount of bandwidth to process that information. Analogous to health determinants is the overall decision context that this information finds itself in. How susceptible is that information, is that decision maker and that system to receive that information? We then can talk about the processing of that information in an analogous way all the way through the system until ultimately we update somebody's belief in how likely something is to happen or some particular quantitative estimate in a risk assessment model. That has to be integrated with many other sources of evidence that may be describing the same phenomenon. So that's essentially a network, analogous to a network response. We then have to decide, has any key measure in our risk assessment now been updated? Has anything happened? So do we have a system level effect? And then we have to decide if that ultimately is going to change a decision. So information requires a change in decision to have value. That change in the decision will change the system of exposure. So whether that is to ban something, to put something on a list such that people are discouraged to use it, all of these things ultimately change into a change in the system. And that gives you value of information, which is the likelihood and severity of the change in the system that information ultimately provides for. And then, analogous to the chemical risk assessment, you would then repeat that for the next decision maker. So each of these things could be done at an individual level or a population level, where we talk about individuals or groups of decision makers. I'm going to give another analogy here, which makes this a little bit easier to understand in a public health context, which, again, we have the same sequence of events on the left from a source of information all the way through to a value of information exercise. Imagine you're issuing an air quality advisory of some kind, a smog advisory, whatever it might be. You have the same sequence of events that you need to process. You need to figure out how that information gets to people. We need to think about the various contexts that people live in, such that they which affects their ability to hear the information, to process the information, and also their decision-making options. What are the options available to someone given a smog advisory? If you work outdoors, do you have the authority to not go to work that day? If you have access to air conditioning, can you in fact close the windows? All of these things are essentially determinants that determine your capacity to cope in this situation and to process effectively this information. As you go down the system, you see that you have to think about it, you have to change someone's level of concern, you then have to adapt their behavior, and then they actually have to decide to adapt. That will potentially cause an altered exposure, and then we can now value, having had a decision with an impact, we can value the likelihood and severity of that change in exposure. So this is essentially a value of information exercise associated with issuing an advisory. So again, we've started with information, we've taken it all the way through the system to cause a decision to change differently than it otherwise would, and we can measure the impact of having made that available. So the system, that decision maker is an individual person protecting their own health. What we're typically talking about here is a broader decision maker who's affecting all of our health. But the analogy is completely apt. I want to take the opportunity, given that we have many different omics, and I was told by someone recently that you're not allowed to have a meeting in this area without adding another omic. So I thought I would do that. With all of these different omics, we do need to understand the system that I'm talking about. So I'm going to talk about mapping the decision. I would argue that as important as all of this other activity is, and I don't doubt it for a minute, it's equally critical to map out the environmental health decision. And we might define that as the totality of processes that interact with new information to reduce or affect uncertainty in decision-making and the consequences of the change in uncertainty for decision-making that affects public health and other societally valued outcomes. So we need to understand these decision systems. It's an interconnected network of events, predictive of emerging properties. Systems biology is. Decision systems analysis is an interconnected network of processes and decisions that convert knowledge and information into decisions and their impacts. An analogous area is the area of risk governance. So that's talking about the totality of actors, rules, conventions, and processes concerned with how information is collected, analyzed, and communicated, and management decisions are taken. So there is an interest in studying the decision-making environment in much more detail, and we're going to need to do that if we're ever going to understand how valuable is information. So we need to talk about some distinct decision contexts. For example, a two-sided dose-response curve when we have, for essential nutrients, decisions regarding biomonitoring, decisions regarding in vivo toxicity testing, decisions regarding product formulation or substitution, decisions regarding site cleanups. Each of these environments has a very different situation, very different decision context, a very different appetite for information, and different requirements to be nourished by that information. As an example, we could talk here about value of information for toxicity as a function of exposure. So that's an example of the complex and interwoven nature of value of information analysis. As you go across the x-axis here, if you believe, as you update your belief in the level of exposure, it affects your level of interest and level of information value that you ascribe to toxicity information. As an example, you might find that at certain levels of exposure, toxicity information becomes much more informative to your decision-making. But as the exposure increases, we have less interest in some new piece of information because we may have enough information to be concerned and to make decisions about that level, given that we know that the exposure is quite high. So it's a very dynamic environment. So one of the things that I'd like to propose as a solution is model-based reasoning. And this was discussed briefly by Kim Buckelheid on the first day of this event. And that's the construction of a class of decision context models which serve as essentially a sandbox for exploring the value of information, the value of complex model components, and the impact of risk assessment processes and the decision maker. So we need to create models of the decision-making environment so that we can know when information is more likely to be valuable. We have to make these things, not essentially expecting that we can construct one of these for every one of these individual and unique decision contexts, but we can do these things for classes of decisions that we do over and over and over again. Not every contaminated site is the same, obviously, but a contaminated site decision has certain common properties. When people are substituting products in formulating consumer products, every one of those things are different, and we're not going to know those because many of them will be confidential and proprietary, but we can describe them and understand how information could and should affect that environment as a general principle. The more we do this, the more we will have the opportunity to understand where information fits into the environmental health decision-making process, and we'll see what is truly necessary to support decision-making. So in summary, I just want to remind you that we're talking mostly about informal value of information, and we won't be expecting the discussants in the next section to talk in any detail about formal value of information, but we do want to talk about altered decision outcome pathways. In other words, how does information affect decision makers? Not how molecules perturb systems. We can talk about that a lot, but we need to talk about how information perturbs decision makers to cause them to change their decisions. So we need to focus on the analysis of systems of processing information and decision making. I mentioned mapping the decisionome. You can dispose of that concept at your leisure. However, if we were to spend even 0.1% of the time thinking about this, or 1.1% of the cost of gathering information on understanding how it fits into decision making, that the rest of the 99.9% of that might be more efficient. Thank you. Yeah.
Questions come to the
Ivan Rusin, member of the committee. Greg, thank you very much. It was very stimulating talk, and I also appreciate you being candid and taking out the first part of my question, which was about fuzzy theory. But so this graph that you showed, was that based on the actual analysis, or as a consultant you must have done this value of information analysis for a client? So can you give us more concrete example as to when that value was balanced out, and resulted in a decision to stop doing certain things and then move on to others? So do you have examples of moving beyond theory?
There are very few examples of moving beyond theory. There is very little demand in the real world for this type of analysis, to be quite frank about it. There's lots of people discussing the value of information, but there's very little appetite for the level of formality that graph implied. And that was essentially a sandbox exercise that graph created. It was not a real application. So there is part of the reason the committee decided to go to informal value of information is to hope to convince people to have that level of thinking going all the way to the decision, because we had more or less determined that value of information theory had been available for a long time and no one was using it. Mm-hmm. And there's various reasons why that's the case. So actually calculating it is maybe not likely to happen very often.
Thanks, Greg, for a really enlightening presentation. And you may have answered my question, but permit me to formulate it anyway. And that has to do with, I do think that risk assessors in general, and EPA in particular, have embraced problem formulation, taking a structured approach to trying to ascertain why we're doing a risk assessment. And I hope to see more of the structure coming out as we move towards external review of the framework that EPA has been working on for the last year. But one idea that somehow I missed entirely was the criteria for stopping a risk assessment. And I kept thinking of your presentation in terms of, so when do we know when to stop? And while you were speaking, I was thinking about OECD, test guidelines, all of the other groups that we interact with here. Do you know of any group, OECD or any other group, that is looking at value of information either formally or informally in the context of requiring tests or doing test guidelines?
I am not aware of any, certainly any formal mechanisms to do that. And I would be happy to hear of any if anyone does know of some. I've never heard of that being used. Again, there is academic literature on the value of information, particularly even as it relates to targeted testing. But it's done in an environment where the decision maker is not really a theoretical concept. They have theoretical properties, etc. And so it can only go so far as an academic exercise until someone decides to formally characterize a decision maker who actually exists.
Greg. So I have kind of a technically oriented question, and I'm thinking about that integral where you're taking the expected value. And so a lot of And I'm trying to see if I understand it with respect to the degree to which you would query the uncertainty space to see, in fact, if your experimentation will uncover unlikely but highly consequential information. And so it seems, because it's the expected value, that things that can make big changes in our understanding can be very, very important. And I'm thinking about it from the systems biology perspective, where you might be uncovering modes of action and the way in which chemicals operate that previously were greatly misunderstood. So could you comment on that whole, the extent to which this value of information values the understanding of unlikely things?
Right. So the issue that you're describing is an important one, because as a formal calculation here, we do take an expected value, which means that we take the probability into account of a surprising outcome in a test. For instance, you might be doing a series of tests, and you might have a surprise that really changes how you think about things and might fundamentally change the quality of decision making. So as a consequence of its unlikeliness, in order to be surprising, it also has to be a little bit unlikely. So it would be downgraded, if I point to the screen here, it would be downgraded in one sense over here that test result is unlikely. So it's being diminished, which is part of your concern over here. But to the extent that the outcome would fundamentally change, sorry, this is a bit of a strange system here. The extent to which the test result, however rare it might be, would fundamentally change your belief in the state of nature, that would be captured in this part of the equation, the PS/T, or given T. And then if that is an important change in the state of nature, it would be doubly counted, to the benefit, I would say, doubly counted, in this exercise, which values how important that understanding is. So for instance, if we're talking about a low-level exposure and we become surprised that it has an effect where we didn't think it was before, and we're terribly concerned about that particular population, for example, the fact that it is a surprise would show up over here, that it's unlikely to happen, but the fact that it's important shows up here, and the important scientifically shows up here, and important societally shows up in the next part of the equation. So the system accommodates how likely it is to surprise and how likely it is to be an important surprise and to be societally valued. So I'm not sure I hope that answered your question.
George Daston on the committee. Two things. One is a comment, and that's probably the value of not just knowing when to stop gathering information, but when to start again. Because one of the concerns around very controversial and highly used chemicals is that somebody's always generating new information after one has had to stop and make a decision, and the new information may in fact be impactful. So that would be useful. And I guess the second is a question, which is, we've been using value of information approaches to try and understand how to design batteries of alternative assays, and when to stop, how to create an optimum battery, how to perhaps sequence things in. And one of the things that has come out of that I've noticed is that the results can be very skewed by the robustness of the pre-existing data set on a particular method. So it might not be the best method, but we know the most about it. And I'm just wondering whether that sort of thing is captured in the quantitative value of information tools that are available.
Yeah, the quantitative tools, I mentioned one of the reasons why it's challenging to use these tools is because it requires a level of honesty that people are not often willing to engage in. And that relates to exactly what is the robustness of the information that you have and what is the robustness of the new information that you're proposing to gather. And that is captured in the formal way, in this PS given T. That's essentially saying what is the change in the probability that you ascribe to states of the world given a certain test result. And that probability might not change very much if you don't trust that test method. And you have to basically say so. It's brutally honest, or it forces brutal honesty in whether you would change your state of belief given that test result. And people often want to argue about that qualitatively. And it leads, as usually, not very far. But it doesn't make anybody mad. Because you haven't given a numerical value to how little you value someone else's information. And if you take an epidemiology versus toxicology paradigm, you have an excellent example there. If you try to take this approach, you actually have to say what exactly you believe when you see an odds ratio of 3 and a confidence interval with a certain width. You would have to actually put that in the system, and people don't really want to do that and admit to that on either side of that equation.
Hi, Maurice Whelan, European Commission. I really enjoyed your talk. I really don't understand why this isn't being taken up more. I just want to make a comment that actually in Europe there's a collaborator of ours, Silke Gabbert from Wageningen University, who has been trying to apply this in similar context to what George just mentioned. And there was a project called Osiris, which was dealing with integrated testing strategies, and that was one component in there. And they looked specifically at genotoxicity testing, where we all know that it's a great example, I think, of adding more and more assays is still not getting a clear answer. But my question is more. So I'd like to see more cases. We're actually embarking on a pilot study ourselves, exactly along the lines of what George said, and it's kind of linked also to our strategy and validation of methods. So we have lots of these methods, and you say, well, in a certain context of making decisions about a hazard or potency, if I did validate this method and I added it to the battery, what ultimately am I going to do in terms of making a decision? I think that's with more and more in vitro assays becoming available, this is becoming very much a critical area for us to address. But my question is more, we hear a lot about weight of evidence, and we'll use weight of evidence, and one of the outcomes of the discussion on endocrine disruption criteria and so on was that within each of these decision-making steps we'd have to use a weight of evidence. But for me, maybe I'm reading the wrong literature, but there aren't very many examples of really a process of weighing in evidence. So the question for you is, where does value of information fit into the general vague term of weight of evidence processes in decision making?
Well, that's an excellent question, and weight of evidence is an example of what I would say far too informal value of information exercises, in the sense that while we would advocate informal value of information to a certain extent, weight of evidence can be a little bit of the Wild West in that it's whatever method you want it to be. So until someone nails that activity, scientific activity, down a little bit more, I think it's a somewhat borderline meaningless term at this point. One of the things that can be done as a value of information exercise, and I didn't mention this in great detail, but one of the barriers to formal value of information analysis is that it tends to focus on that final number. And if you only focus on that final number, you'll never be satisfied because there are so many upstream assumptions you had to make that you don't feel satisfied. But if you construct the system that weights evidence and test it many, many times to see, does it do sensible things with information? So if I put in a very important, very high-quality study into this valuation process, does it do sensible things with it? Does it do things that are important that we would expect in a weight of evidence characterization to do? Does it do it even better than humans do it when they sit around and discuss evidence? And I think that could be shown to happen. And if we're not focused on the valuation number that comes out at the end, but the process, the formal process of characterizing information, characterizing quality, characterizing how much you're willing to update your beliefs in something given a certain type of evidence, I think it could be used as a way of structuring a weight of evidence exercise without actually replacing it, because I don't think people are willing to submit something as important as the debate over endocrine disruptions to some computer algorithm that says, oh, this is the only study you need to do.
So for my own, I want to be able to kind of, if I was to verbalize how to use this, would I be saying, in a regulatory context, Derek Knight mentioned weight of evidence multiple times yesterday, because it's this vague term that means at least you used all the information you had and somehow but the algorithm is always ill-defined or not defined at all. So to verbalize that, I say, hey, Derek, I'm using a weight of evidence approach, but I'm using value of information methodology. Is that a way of verbalizing it? Or from your perspective, you just don't talk about weight of evidence and talk about you're using a value of information approach to making a decision?
Right. Well, a lot of the work that relates to value of information analysis comes back to essentially Bayesian statistics, and the weight of evidence characterization could essentially be cast as if you were to adopt value of information ideas and apply them to weight of evidence, you would end up with essentially something that looked like a Bayesian network. And the reference I had yesterday to Kim Bucklehide's presentation was, he made a reference to Judea Pearl, who's sort of one of the fathers of artificial intelligence, particularly the use of Bayesian networks. And that's a situation where you're very formalizing how you're going to treat evidence in a quantitative way. I wouldn't necessarily say that that's a value of information exercise, because you could do a weight of evidence characterization without contemplating a decision. Yeah. You could do it, so value of information inherently requires a decision, but the underlying properties of Bayesian updating of evidence and combining of evidence with conditional probability tables, for example, is a generic exercise that doesn't require a decision. So that would be the closest map to a weight of evidence exercise that I could come up with.
Thank you.
Greg, thanks. Really nice talk. Bill Farland. From a historical perspective, early in the days of EPA, we actually did risk assessments that were targeted at particular programs. And for efficiency's sake, we started to say, why are we continuing to look at this chemical for the water program, for the air program, et cetera? But in fact, that was a time when there were some specific questions that we could address, and we understood we were trying to provide information for decision makers. I guess what I'd like to get at in thinking about this idea of when to stop, typically when you do a one-size-fits-all risk assessment and try to address the questions of many decision makers, you have a hard time figuring out when to stop. And I guess that requires us then to think about not only the system of the science that we're talking about and the system of the decision, but the interactome, if you want to use another term, that allows us to really have a dynamic system. And I guess I'd like to hear your thoughts on how value of information changes within the context of the time that it takes to do a risk assessment.
That's a good point. And again, in the formal scheme, and arguably should be in the informal scheme, you would explicitly account for time, and you could include the delay associated with, for instance, if you're contemplating a decision which you expect to have a certain benefit, but it might be slightly better a decision with a little bit more information. Right. But that process would delay the receipt of that baseline benefit. You would have to include that as a cost of waiting. So you would explicitly value delay, and some of the formal literature does exactly that. And if you're going to delay something for 10 years, you would basically be foregoing 10 years of some benefit that might be available with the baseline decision.
Yeah. Great. Thanks. Well, let's thank Greg. That was a great talk.